Welcome back, Patriots. Let's do our last lesson of Unit 7. So one block from now, we'll have our test review, and then 2 blocks from now, we're going to have our test. Make sure you don't miss that test, y'all. Please get that turned in, because I really don't want to give you a 0, but I will, because if you do no work, you're going to get no credit, and that's going to take your average. And I don't want that. You don't want that. Nobody wants that. Get that test in on time. All right, last lesson is going to be on composition of functions. Now, what we're going to cover here is, you remember back in the day when you had problems written like this, okay? G of 4. What we would do is we would replace all of the x's with whatever was inside of that. So G of 4 would be, replace all the x's with a 4, and then we would just simplify down. That was an Algebra 1 skill that we went over. 2 times 4 is 8. Minus 4, so G of 4 is equal to, no, not 12, is equal to 4, okay? We're basically going to start off by doing that exact same thing, but we're going to be building up to the idea of composing 2 functions together. Now, whenever you see it written like this, that is G of f of x. Now, what we're going to do is we're going to be placing the entire function f into function g. And you'll see what that looks like when we get down to number 5. Okay, so now let's do g of negative 3. Again, I'm going to do 2, replace the x with a negative 3, minus 4. Okay. 2 times negative 3 is negative 6 minus 4. So G of negative 3 is equal to negative 10. Simple enough. Now, we're going to start building on a little bit of complexity on these and on each example. So we get to number 3, and now we've got G of A. Well, we're going to do the exact same thing. We're going to write the entire equation with my parentheses there, but I'm just going to write an A in. So whatever's inside the parentheses goes in the parentheses on the right. So G of A is just 2A minus 4. Now, that didn't really help us any because G is 2x minus 4, 2A minus 4. It doesn't really do anything other than illustrate the point of whatever's there we're going to plug in. So whenever I go and do G of x plus 2, I'm still going to write my problem the same way I had before. 2x minus 4, x is replaced with parentheses, but now I'm going to be putting an x plus 2 inside. And now I'm just going to simplify out. 2 times x is 2x, 2 times positive 2 is 4, and then minus 4. So G of x plus 2, these two are going to cancel out, leaving me with just 2x. Okay, now we're going to G of f of x. So here's what ends up happening on this one. We're going to start off the exact same way. 2 instead of x, I'm writing parentheses, and I made that big for a reason. And the reason for that is that the thing that goes inside of it is whatever is here. So that's f of x. But f of x is x squared plus 3. So I'm going to replace f of x with x squared plus 3. That's how I compose functions, just by substituting one function in for the variable in another. Now we're just going to simplify out, distribute. 2 times x squared is 2x squared. 2 times 3 is plus 6, and the minus 4 drops down. So now G of f of x is equal to 2x squared, and then positive 6 minus 4 is plus 2. Okay, so not that bad of a skill. Let's just go through a bunch of examples of it. Okay, here I've got f and g, and then some students will ask, is f of g of x and g of f of x the same thing? Well, let's run through here and see what happens, okay? So for A, I'm going to write g of f of x. Oh, why did I do that? That's the exact thing I had written before. 3 times x plus 2. Oh, wait. Sorry, g is negative 5x plus 26. I'm going to put f of x in there. So that's going to give me negative 5 times 3x plus 2 plus 26. Okay, now let's distribute the negative 5. Gives me negative 15x. Negative 5 times 2 is negative 10 plus 26. So now g of f of x is equal to, I'm going to combine these like terms, and that gives me negative 15x. Negative 10 plus 26 is plus 13. Okay, now let's do it the other way around. F of x is 3x plus 2, and we're going to be putting g of x in for x. So now that becomes 3 of g of x is negative 5x plus 26. Okay? Now distribute the 3, gives me negative 15x. Distribute the 3 times the 26 will be 78, and then plus 2. So now f of g of x is equal to negative 15x plus 80. So no, they're not the same thing. G of f of x and f of g of x are completely distinct answers. Okay, let's do number 2. So this is going to equal, let's say g is x minus 4, and then we got our h of x there. So h of x is just x squared minus 10 minus 4. So my answer here for g of h of x is just x squared minus 14. Okay? Now for h of g of x, h is x squared minus 10, and we're putting our g of x here. So then g of x is x minus 4. Now, don't take the bait and just square the x and the negative 4. You've actually got to do x minus 4 times x minus 4, which means we have to FOIL out or distribute that. I don't care what method you end up using, but you're going to do something like this. X times x and x minus 4 gives you x squared minus 4x. Then we got negative 4 times x, and negative 4 times 4 is negative 4x plus 16 minus 10. Now combine all of our like terms, and we've got x squared, and then those two combine to make negative 8x. Those two combine to make positive 6. So that is h of g of x. All right. Now, for number 3, something I'm going to start doing here is I'm going to stop writing out both of these. I'm just going to jump straight into the bottom one. So we've got g is x squared plus 6x minus 2. But h is x minus 6, so I'm going to place that x minus 6 in everywhere that I had an x. Now we've got to simplify out. So that is x minus 6 times x minus 6 plus, let's distribute this. That gives me 6x minus 36 minus 2. Now we need to distribute out the x and the 6. That's going to give me x squared minus 6x minus 6x plus 36. And then the rest of this drops down, plus 6x minus 36 minus 2. So this is going to be my last one. So I'm going to rewrite that. Only one x squared term, so it gets written down. Now all my x terms, I've got here, here, and here. Negative 6x plus negative 6x plus 6x is going to be minus 6x. And then I've got plus 36 and minus 36. Those cancel out, leaving me with just the negative 2. So the best advice I can give you for all this is just be very, very careful and meticulous. Don't drop any terms or make any small algebra mistakes. Okay, now we're doing h of g of x. So we've got h is x minus 6. Now g of x is x squared plus 6x minus 2. Wow, after all that, this one is actually pretty easy because it's just h of g of x. There's nothing to do here except combine my like terms. X squared plus 6x minus 8. Okay, now on 4, this one takes it even a step farther, and instead of having an x inside the inner argument, we're going to have a number. Now, what I would suggest here is actually solving or resolving out f of negative 3 down to an actual number. And here's what I mean by that. F of negative 3 is going to equal 5 times negative, you know what, let me do it in a different color, it's going to be easier to see. I said purple. F of negative 3 is equal to 5x, but that x is a negative 3. So f of negative 3 is equal to negative 15. Now, whenever I go to do this problem, g is x squared plus 6. I'll come back to that in a second. I want to section it off so we don't get confused on what's what. Okay, inside of here we're going to put f of negative 3. But I already know that f of negative 3 is equal to negative 15. So I can simplify this down and just do negative 15 squared plus 6. So negative 15 squared is 225 plus 6. 225 plus 6 is just 231. So g of f of negative 3. Okay. Same idea here. I want to calculate g of 7. Now g is x squared plus 6. I'm going to put a 7 in there. So that's going to equal 49 plus 6. So g of 7, 49 plus 6 is 55. Now, whenever I come over here, a long equal mark there, that is f of, right, f is 5x. And then that's f of g of 7. But g of 7 is just 55. So this equals 5 times 55, which equals, I should know how to do that by hand. It's late. I've recorded a bunch of these today. 5 times 55. Is 275. So f of g of 7 equals 275. Okay, so that's all we got for you today. Not nearly as bad as polynomial long division. Just be careful and don't make any small, silly mistakes. Like I said, we got a test review coming up next block, and then a Unit 7 test the block after that.